Let's try a gear problem. And I guess you need to understand the basics of what goes on in the gear problem. So let's just talk a bit about that. So, as you know, there are these little teeth that kind of fit inside of each other as they turn each other. Usually what's happening is one guy is going around in circles and he's turning the other guy around in the same circles, same kind of situation. Now, as you can see down here, I have the little guy's got a radius of 4. The bigger guy got a radius of 12, 3 times bigger. I'm going to turn this little guy to 4 pi, which is twice around. Once is 2 pi, twice is 4 pi. So he's going to go around twice. And we're interested in how much angle in radians will this guy go. Now there is some proportionality that might work here, but I want to kind of go with a different train of thought here. The part that is in common between the group, let me highlight this in a color here. The part that's in common is the arc that is touched by both of those. So whatever is shared as they turn, that's the same. So in other words, the arc length here will be the same arc length over here. Their angles are different, their radii are different, their shapes or their sizes are different, but what is the same is how much arc they physically touch together. So what I do is I use the one that's got the most information, which in this case is our small guy. And if I multiply 2 rotations, which is 4 pi, times a radius of 4, our arc length is 16 pi. Now that is this value of 16 pi, but it's also this arc length of 16 pi. Now we can go find how big an angle we have turned by the other one. So its arc length is equal to the angle in radians times r. Its arc length is 16 pi. We do not know its angle, but this radius is 12. We get 16 pi over 12. We can take a 4 out of the top and bottom. And so we get our angle. Now let's think about how big that is. Pi over 3 is 60, so 4 groups of 60 is 240. So how this works is this guy went around once, let's get the right color, once, twice. In the same amount of time, this guy went around, what did we say, 240. So it went here, it's 180, 240. This amount of arc here is the same amount as going around twice the little guy. And that's how you work with a gear problem, or something like that.